Hey everyone, today we are learning about Venn diagrams so that we can make comparisons between sets. You'll know you have it when you can describe the relationships of Venn diagrams using all, some, or none are those keywords. So hopefully Venn diagrams are familiar to you. This is going to be the ultimate test to see if you actually listen to my videos. Right now I would like you guys to take a minute, just pause the video, and try answering what you already know about Venn diagrams, and maybe draw an example of a Venn diagram you've seen or made in another class. So pause your video and take a few minutes or 1 minute to try both of these questions, just to get you thinking about Venn diagrams. So go ahead and pause that video. Alright, I hope that got you thinking. I'm very interested to see what you guys wrote in class. I will be looking at those when I check homework. So let's go ahead and look at some notes all together. So in geometry class, the three main relationships we use with Venn diagrams are all, some, or none. So first of all, if you look at all is when you have one bubble that is completely inside of another bubble. So all of this bubble is inside of the bigger one. So we're going to say that a bubble is completely inside another bubble. So if we look at this example, we see that roses is totally inside of flowers. So you would say that all roses are flowers. So this is the sentence you could use to describe this Venn diagram. Alright, next we have some. Some is going to be when you see the overlap in pictures. So that overlap is this right here. It's where one circle and another circle overlap, so there's a middle part of our picture. So to describe this picture, there's actually two sentences we could write. So first you could say that some dolphins are whales. So some dolphins are whales. But you could also say that some whales are dolphins. So that sentence works in either order. It's kind of like the converse, hence why we learned all of those things. Oops, some whales are dolphins. Alright, and then last but not least, you have the none. So none is when there is no connection or overlap of these bubbles. So they're not inside of each other, they're not overlapping, they're not touching at all. So again, there's two sentences you could say here. The first one is that no books are flags. And if you haven't already guessed it, thinking of that converse again, no flags are books. Alright, so we're going to look at these two on the front together and do the back of this in class. So if we look here at the bottom, it says write a sentence about a relationship in this Venn diagram. So if we look at this picture right here, this big box is containing all of it. So since these bubbles are inside, that should be a giveaway that I'm going to be seeing some sort of all relationship. I also see an overlap, so I might be seeing something with some. I'm not sure about none, but maybe that will come up. So the sentence that I want to write about is a some sentence, because those can be the hardest. So you might think some immediately is that overlap. Well, when we've got a big container like this, if we look at it, this is describing students in a homeroom class, and this is if they're in math club or science club. But all of this space out here are still students in homeroom, but they're not in the math club or science club. So I'm going to say that some students in homeroom 234 are not in math club or science club. That is the sentence that I came up with. I'm going to let you guys try these sentences on your own. So picking just one all relationship, one some, and one none. But looking at the same Venn diagram over here, let's look at some already created relationships and decide that which of the following are true. So which of these are true? So if I take a look at A, it says that all students in homeroom belong to either math or science. So all belong to either this one or this one. Well, if we think about what we just said over here, some of them don't belong to any, right? Because of this outside part. So all the students in the outside part don't belong. I'm going to write outside space here for my little explanation so I can remember why. And I'm going to X this one out because it is not true. Alright, next up, all students in homeroom belong to both math and science. So if I see that word both is a giveaway for an overlap. So that overlap is with the students who are in math and science. But is that all of the students in this entire homeroom? No, it is not. So the overlap shows that there are some, but not all. So only some of them are in the overlap. So X that out, it's also incorrect. Alright, part C. No student in homeroom belongs to both math and science. Well, that's exactly what we were just talking about. That both section is right here in the middle. So yes, there are students that fall into this section. So this is incorrect because there is an overlap. There is an overlap. So you can kind of just add to that arrow. And then last but not least, some students in homeroom belong to both math and science. Well, obviously this is the last answer choice, so it's probably going to be correct, but let's make sure it makes sense. So some belong to both math and science. Well, we've said a few times now that this overlap shows us that there are some that are in both. And since this is just a sum relationship, then I know this is correct because there's an overlap section. So some do belong to both. And since it's some, it is not trying to include all of the students. Alright guys, thank you for watching. Like I said, please make sure that you have filled out the top part of this. And we will finish the rest of the back of this in class. Thank you.